So my name is Russ Angold, and for the past 15 years, I've been working on exoskeletons, or wearable robots. So with a show of hands, how many people in the room know what an exoskeleton is? Pretty good number. Okay, well, if I'd asked this question back in 2004 when I started working on exoskeletons, the number would have been much smaller, and this is the exoskeleton you were probably thinking of.
Get away from her, you bitch!
So this is a clip from the movie Aliens. It was filmed in 1986. The year it took place was 2122. And Sigourney Weaver, the main character, is operating a Caterpillar power loader. Pretty amazing stuff. But the reality, in 2004, the most state-of-the-art exoskeleton in the world looked like this. So this is Bleek's, the world's first untethered powered exoskeleton. It's actually in the Guinness Book of World Records. Amazing hydraulic power supply, 6 actuators, completely self-contained, and walking around. And this is where my exoskeleton journey begins. A former colleague of mine had showed me this video and asked if I wanted to come participate and design the next version. My answer was an immediate yes. You see, I'd made a promise to my brother when we were kids that he would go be a Navy SEAL, a US elite soldier, and I would become an engineer, and someday I would make him cool stuff. This definitely fell into the category of cool stuff. So we started working on the project. I quit my job, moved back up to the Bay Area, and started working on Bleek's. And the first week, learned a lot of things. The first thing I learned was this exoskeleton uses 2 kilowatts of power. So the entire backpack that you see on the back is the power supply. Amazing technology at the time, but it couldn't carry anything more than itself, so not very practical. That was the first thing I learned. The next thing I learned was the top speed was only 3 kilometers per hour, much slower than the average human walking pace. So again, not very practical. And then I showed the video to my brother, and he said, "That's neat, but we're never going to use it." And I was like, "Oh, what's wrong?" He said, "It's too loud, it's too slow, and it's too big and heavy." And I was like, "Okay, so life lesson, talk to your customer before you bet your career on a technology. Show them the video first," is what I should have learned. But we had a year to recover, so I said, "Don't worry, we'll fix it. We'll figure it out how to make it lighter, faster, better." So that was week 1. It was a rough week. The second week, I get a call from my parents. My brother Ryan, the Navy SEAL I'm going to design Exos for, had been in an accident and broke his neck. He was alive, he was in the hospital, and I got on a plane to fly across the country to think about, how we could help Ryan. So the entire flight out there, I'm drawing up ideas on how we can use this exoskeleton technology to get him back up on his feet and get him walking again. I go into his hospital room, I say, "Brother, don't worry about it, we'll get you up and walking again." And he looks at me and says, "I can walk just fine, I just can't move my arms," which was really interesting. I knew nothing about spinal cord injury at the time. So here's this Navy SEAL with these gigantic biceps, and he can't even pick his arms up to defeat their own weight of gravity. It was pretty interesting. I'm happy to say, after a couple years of rehabilitation, my brother has made a complete recovery. This is him last summer. He still complains, though, that he can only do 20 pull-ups. So I think he's fine. He's probably the most capable incomplete spinal cord injury patient in the world. But Ryan's injury had a profound effect or change on exoskeleton trajectory, the development of exoskeletons. We started thinking about how this technology could be used to help the millions of people around the world that have lost the ability to walk, whether through stroke or spinal cord injury or some sort of paralysis. And so I'm happy to say, in 2012, just 8 years later, we launched an exoskeleton, the first commercial medical exoskeleton. And since that date, we've helped over 20,000 users take over 107 million steps. So we're pretty proud of that. It's pretty neat to see where the technology has gone. And that's basically the equivalent of 2 trips around the world for people that would otherwise not have the ability to walk. So a couple of other interesting things happened between 2004 and 2008. Some movies came out. So in 2008, the movie Iron Man came out, and 2 years later, Iron Man 2. Now, this was great for exoskeleton awareness. Now, everybody knew what an exoskeleton was. Everybody knew what Iron Man was. So they started calling us. The problem was that they all wanted to fly. And up until Tuesday, I had never seen an actual human fly in person, and that was amazing for those of you that saw it. So expectations had been raised, but people were aware of the technology. We had made some breakthroughs in the efficiency of the actuation. Sensors had gotten smaller and cheaper, and so we started to see this boom in exoskeleton development. Now, it wouldn't be a Singularity presentation without our exponential growth chart. So this is the number of exoskeleton companies that exist, starting all the way back to 2002. So the initial exoskeleton development was funded by DARPA, or the U.S. Defense Advanced Research Projects Agency. That's who actually funded the project we were working on. And DARPA's goal is to seed development and kind of kickstart industries. So they fund universities, they fund small companies to really go after some of these ambitious goals and hard problems and see if they can solve it, with the goal of creating more opportunity in companies and really to help the economy. And you can see here that it worked. So we had a handful of companies working on the project in 2000, and now there's over 100 companies working today. And here's some of the logos of the different companies. And this is global, right? And you'll see some names there you recognize. So the key takeaway from this slide is that exoskeletons are here, right? Exoskeletons are no longer just projects at universities and research companies. The applications are out there, the products are now commercially available, and the industry is growing, right? I'm sure I'm missing some exoskeleton companies that are actually working on this today. And when we look at the category as a whole, I like to break it into 4 segments: military, medical, industrial, and consumer. The reason we do this is the individual needs of these market segments are very specific, right? You may need one thing for the industrial space, which is very different than the requirement in the medical space. And today, we're going to focus on the industrial applications. So, with this newfound awareness of the Iron Man movies, and our medical exo being on a lot of news channels and getting a lot of attention, companies started reaching out to us asking, hey, where's my exoskeleton? If you can help somebody that's paralyzed get up and walk again, why can't you help me with my back injuries on the job? Why can't you help me, with my warehousing and logistics? Like, they just assumed it would be possible. And our response was, oh, we don't know. We don't know what the problem is. And so we started talking to these companies to try to understand what challenges they were facing. And 3 main themes came up. Number 1 was safety. So when we started to dig into the data, you look at the cost of injuries on the job site in the US, and there's a ton of injuries involving outside sources. So people moving things, lifting, carrying. It seems pretty obvious. But the thing we didn't realize was the number 1 affected body part is the upper extremities: shoulders, wrists, arms. And so I'm going to ask all of you to participate with me in this little experiment to give you some insight into why this is. So if everyone would put their hand up, just one hand. I'm going to ask you to keep it up for a second. So everyone's got their hands up. This is great. Perfect. Everyone? Yeah, you? Okay, got it. So the next concern that companies had was productivity, right? How do we do more with less? Especially here in Thailand. Your average working age is 40 years old, and you're going to lose 6 million workers in the next 15 years. So how do we keep the productivity levels up, while maintaining with a shrinking workforce? And that goes to really to the next slide. Here, you can see the trend. This is from your guys' data, and that next 15 years, you're going to lose 6 million workers. And then the workers that are still working, some of them are working longer, harder, they're retiring later. So how do we keep those workers healthy and happy on the job? So once we understood these kind of requirements, then the question was, well, how can we help with exoskeletons? And what does an exoskeleton really do? Does anyone know? Show of hands, just kidding. So an exoskeleton has one goal and one goal only. And it doesn't matter what kind of exoskeleton it is. It's to defeat the effects of gravity. If we were all in space working on the space station, we would not need an exoskeleton. It's the gravity. Are those hands? Keep the hands up. You're feeling it now, right? Some of the hands are dropping. Keep the hands up. So the effects of gravity is crushing. And so every exoskeleton, it doesn't matter if you're carrying a 100-kilogram beam or if you're designing an exoskeleton to help you squat. So if you're working on something in this position, being able to relieve the strain from your thighs. If you're actually bending over to pick somebody up, when I go to bend over, I have to pick up my own weight. It's not the box I'm picking up, it's actually my own torso weight. So can we create exoskeletons that actually can support you when you're doing some of these applications, like keeping your hand up for a long time? Everyone's hands are still up? Keep them up there. So the good news about this is these exoskeletons are available. They fall into the category of what I call passive exoskeletons. These are all commercially available, and they require no batteries, no sensors, right, and no electronics. So they're much more affordable than other types of powered exoskeletons. So these 4 exoskeletons are commercially available products. They cost between $3,000 to $7,000 US, and you could go out and buy one today. And if you all had them on right now, your arms would probably still be up if we keep them up there. So, and I'm doing this to try to paint a point, right? So when we realize that there are these applications out there where workers are working overhead all day long, it's exhausting on the shoulders, the back, the arms. And so we developed these products to really target these applications. And we have a video here of an exovest in action. This is a Ford assembly line. So this worker picks up the fasteners, right? He comes over, he's putting his hands up. We're down about 10% of the arms up. We lost a lot of you. So this worker, right? You guys, I'm only asking you to hold it up for like 3 minutes. He does this all day, every day, working, putting those fasteners in the car, day in, day out, 8-hour shift. And if you look at the numbers, it really becomes staggering. So an 8-hour shift, 1 car per minute, and a 1.6 kilogram tool. That's the equivalent of lifting 6,000 kilograms per day, right? Or 4 Toyota Hiluxes. But we left out a very important component, and that's why I asked you to put your arms up. The weight of our own arms. Our arms weigh on average between 7 to 10 kilograms, right? And so you have to hold that up all day long. That's heavier than the tool. And so if we rerun that math and we put the actual arm mass in the equation, it's the equivalent of 42,000 pounds or 34 Toyota Hiluxes that worker is lifting every day, right? Incredible. So the key takeaway is it's not about the strength, it's about having that all-day endurance, right? That worker's not lifting something that's amazingly heavy. He's just being able to do it all day long. Now, I brought a vest here to do a demo, and Bright Esan's going to come up and help me. She's a volunteer from the audience. Please welcome her. So we're going to put the vest on, and she's never worn it. She asked if she could try it before the demo. I said, no, we got to make it live and real. So let's come out here. Put your arms in. You put it on like a backpack. There you go. Tighten your waist belt there. Clip that. They're perfect. I'm going to adjust the back. It's all adjustable. That looks about right. Okay. Tighten these guys up here. There you go. All right. Now I'm going to clip the arms in. Now, normally you could do this yourself, but since it's your first time, I'll help. So we just put your arms in, snug them up.
Yeah.
We'll put this guy in here and tighten it up as well. Okay, how's that feel? Good? All right.
Can you make me cry?
That was Richard Browning. You needed to be here on Tuesday if you wanted to fly. Okay, see, that's the number one question we all get. I should have made jetpacks. Okay, feels good? Can you move your arms? You can raise? Okay, perfect. So it's not on, and again, this has no batteries or sensors. It's only springs, but I haven't engaged the springs yet. So I'm going to ask you to lift this weight here. Okay, you didn't know what you were signing up for. So this is 15 kilogram weight, obviously. It's not a prop, it's real. So
I think flying better.
flying better? Yeah. Right? So I'm going to ask you to hold that and now try to lift it up over your head without it on.
Wow.
Can't do it. Okay. So we'll turn the vest on and now give it a try. Give it a go. Lift up. Oh, there you go. That's good. So again, it's not geared for the extra strength. It's really for the endurance. So this is an extreme example of how heavy it is, but you're able to do it with that because we're pushing up with the extra weight of the arms. But it's heavy, yeah?
Heavy.
So now I take it away. Now lift your arms up. How's that feel? Feels amazing?
Yeah. It's like something.
Oh, sorry. I got a mic.
Yeah, like somebody help me lift my arms up.
Right. And when you bring them down, what happens?
Yeah, it's cool.
It's cool. So I'll turn them back off. So you probably already forgot how heavy your own arms are. So bring your arms down.
Yeah.
I'll turn them off. Now bring your arms back up. You feel the difference?
Yeah.
Right.
I have to lift my own arms.
Right. And humans, we're inherently lazy, so we really adapt to this technology quickly. Well, thank you for doing the demo. I appreciate it. Let's give a round of applause. And I'll be around during the lunch break if anyone wants to try this out, because you really got to experience that feeling of what it does. Thank you very much. So that's what the vest does, right? So if you were wearing that, you would have been able to hold your hand up for the entire presentation and not get tired. This is the next category of exoskeletons I'd like to talk about. These are the semi-powered devices. So these devices have batteries, they have actuators or robotic muscles built in, and they have sensors so that when that user goes to pick up a box, not only can it can displace the user's weight, but also help pick up the weight of the box they're carrying. And several of these devices are out there. They're commercially available. And this is kind of the first leg of powered exoskeletons that you're going to see. Now, this exoskeleton here on the right doesn't look like an exoskeleton, right? This is a new category of exos called soft exoskeletons. This is really exciting. So it's a fabric-based system, and all those actuators are actually built into the fabric, so that person can use and wear that exoskeleton under their clothes all day, every day. And I have a video of it in operation. Play it. So their target is to help people to stay mobile, to keep them up and walking, especially as we start to age. It gets harder to walk. So the soft muscles built into the suit actually help you get out of a chair, stabilize your core, and keep you walking. And they're going to launch this EXO, a limited release, at the end of this year. So it's coming. And I think it's a really exciting opportunity for Thailand with your textile industry starting to look at some of these highly technical fabrics and textiles to make soft exoskeletons. Because you get rid of all the bulk, the machine, the hardware, and it's custom to you, more like tailored clothing. So an interesting segment to keep an eye on for sure. The last category I'm going to talk about is the fully powered exoskeletons. Now, these are the closest things we have to that video clip you saw at the beginning of Sigourney Weaver. For the most part, these are in university labs. and only in research, except for the one here on the right. That's actually a company called Sarcos that's going to start leasing these devices at the end of this year. So they're much more expensive than the Exo Vest you have up here. These are designed for logistics, moving heavy objects. This one here on the right can lift up to, I think it's 40 kilograms, and it runs for 4 hours on a set of batteries that you can swap out, so you can get all-day use. Now, I don't have an actual video of that exoskeleton operation, but I do have a video of one of their prior versions from back in 2006. So this was, again, part of that DARPA program we talked about at the beginning. And you can see this exoskeleton's pretty capable, pretty agile. He can kick a soccer ball, punch a punching bag, lift some heavy weights, bust boards, and walk. But the problem with this exoskeleton was the same that we had with Bleek's. This used 7 kilowatts of power. It had a gigantic power supply, not on the exo, but behind the curtains with that tether actually feeding it. So the technology has progressed, and now they can actually make this exoskeleton completely portable, and you'll start to see them here coming soon. Another sign that the exoskeleton industry is maturing is we're starting to develop standards globally. And this is important because it helps bring together the exoskeleton manufacturers and the actual exoskeleton users, the companies that are going to use the exoskeletons, to ensure that we're making quality products that meet safety and reliability standards so that you, as the consumer, know you're getting a product that you can trust and use on a daily basis. Another sign is we're starting to have conferences specifically focused on wearable robots or exoskeletons. This is Wearicon. The first one was in 2016. The next one is March 30th of 2020. And this is a great place to go if you're interested in this type of technology or think you have applications for it. There's a bunch of exoskeleton manufacturers there, as well as other customers giving their clinical studies and on their trials. So customers like Ford or Boeing or Toyota will be there talking about their experience with the technology and how they use it. So it's a great place to go to gain some insight. So we've talked a lot about exoskeletons and why to use them. And one of the questions I get a lot is, why even use an exoskeleton at all? Why don't we just use robots, right? Replace the worker, take the human out of the loop. And if you believe some of the headlines, you would think that, this is already happening today. And but it's not necessarily the case. So I'm going to show you another video, and this again is from DARPA. And DARPA funded a competition. It was a global competition to see who could make a robot that could operate in a human-like environment. And they made this obstacle course, and whoever brought the robot that could complete the course the fastest was going to win. So the course consisted of walking down a 50-meter sandy path, opening a door, grabbing a hand tool, turning a valve, walking across some rubble, and up about 4 stairs. So anyone in this room could have completed the course in less than 2 minutes. Let's see how they did. There's the rubble pile. Even with 4 legs, it's still tipped over. I think it thought it had the knob, but it didn't. Stairs are tricky for robots. I don't know. This one thinks it has that valve, but not quite. I don't know what happened there. Have you ever seen a nervous robot? So Obviously, that's not fair. This was just some of the best fails of the competition, but 2 of the robots completed it, and it took them about 25 minutes. So, it really was amazing to see the robots actually compete. And again, this was 4 years ago. And many of these robots, like the one you see here, were built by a company called Boston Dynamics. Now, Boston Dynamics just released this video of their latest logistics robot. So again, 4 years later, notice any differences? They got rid of the legs because wheels are better. Humans are really good at walking, but robots are not. So wheels are a better idea. These are completely autonomous robots. They're doing some pallet building and depalletizing, and they're doing this completely autonomous. They're using their own sensors to see, to read the barcodes, to move the boxes, and I think each one of these boxes, they said, weighed about 11 kilograms. So we've come a long way in robots in the last 4 years. And so I used this construct that was put together by the Boston Consulting Group to kind of talk about this topic. And it really helps to define where you should look for applications and when you should use a robot versus when you should look for human labor and exoskeleton advantage. On the lower axis, the x-axis, we have the environment. So we go all the way from a rigid environment, like a fixed factory where nothing's moving, all the way to an unstructured environment, like a shipyard or a construction site that's constantly changing. And then on the y-axis, we have task complexity. So develop no logic, like a CNC machine or a pre-programmed robot, to actually high-level decision-making and problem-solving. And traditional robots fit in this segment, right? They're fixed in place, they don't move, they're pre-programmed, they do the same thing day in, day out. You can shut the lights off, walk home, nothing's going to happen. Advanced robots are starting to move into this space, right? So just like you saw in that last video with the Boston Dynamics robot, they're starting to be mobile, starting to get out of that structured environment, starting to move through and navigate those spaces, and they're starting to apply decision-making, right? The new sensors have enabled better decision-making on these robots. And so that's really where we see the growth in robotics. And on the extreme other end is the human labor advantage, right? We as humans are really good at walking upstairs. No one has fallen yet, walking up and down these stairs for the whole show, right? We're really good at navigating complex environments. We're really good at making decisions. That Ford worker that was working under the car, right? That piece is flexible. So when he's down there working on it, he's having to align each hole and kind of dial them in, and then every car is a little bit different. So it would be a really expensive task to automate. That's why they still use the human. So the beauty comes when you can merge our human decision-making and problem-solving skills with that exoskeleton or support structure that can really give you that all-day endurance or extra strength. So when you're looking for these applications, that's really what you want to look for. Somewhere to leverage that human intelligence and just combine it with that robotic assistance, right? So the last slide I'll end with, we started the video with this slide, and the year was 2122, right? So this is a rendering of a machine that Sarcos is developing right now, and they plan on actually launching it in 2022. So it looks like exoskeleton reality is about 100 years ahead of science fiction. And with that, I'll leave you. Thank you very much.